declaring your products are THC free. What does that really mean? Hello, I'm Craig, the CEO of Botanacor Laboratories in Denver, Colorado, in the western half of the United States of America. We are an ISO 17025 accredited laboratory that tests all kinds of products for cannabinoids, heavy metals, pesticides, residual solvents, and a number of other things. At Botanacor, we test products all the way from the farm to finished goods. We test the seeds, we test the flower, we test the extracted oils and material from the hemp plant, as well as the finished goods that those oils make. We also work with universities on research around hemp and CBD products. Hemp is in everything. Everything from socks to transdermal patches to tinctures to salves to bath bombs, topicals, lotions, and oils that you use every day. The thing we're going to talk about today is cannabinoid testing. So CBD is a cannabinoid, as is THC. And one of the things that users of CBD products want to make sure is that they don't have THC in their products that they're using with CBD. They're all cannabinoids, and you can have them ranging from 100%, as in an isolate, all the way down to 10 parts per million or less. And what I'm going to talk about today is how a laboratory analyzes for that and can see both things, something that might be very, very high in a cannabinoid as well as trace, as in THC. Now, in the United States, the government has set a federal limit of 0.3% for hemp products to be considered legal hemp products. So at 0.3% or less, the products can be shipped, handled, and used in manufacturing as legal hemp products. And above that, they're considered marijuana and have to be destroyed. In Japan, the legal limit is 10 ppm. That's significantly lower than in the United States, and what this causes is some challenge around how the lab measures that level of THC. We call it trace THC. So I'll walk you through that and the important elements of how to do that. So analyzing THC Free Cbd, the very first thing we do is extract all of the cannabinoids out of the sample that you've sent, whether it's a dog chew, an oil, a bath bomb, or the flower. We extract that out in its entirety, and then we put it through a chromatographic column on an instrument called an HPLC, a high-pressure liquid chromatograph, and separate all the molecules that are in that mixture so that we can see them individually. That's very important because if they're mixed together, we can't separate and identify them individually. The cannabinoids are all very similar products. So the chromatography is a very important element in being able to separate the cannabinoids and then determine how much of them are in the sample. So what you're seeing is a representation of a chromatographic column. In the column are solid phases that are used to separate the molecules from one another. It's called liquid chromatography because the liquid flushes those through the columns at different rates. The idea is if I can separate them and see them individually, then I have a chance of quantitating them accurately. Now let's talk more about the separation and the importance of that separation on the detection of your compounds. What you're looking at is a peak of CBD, and within it, in what's called a shoulder, is another little peak, another cannabinoid. Maybe it's THC, maybe it's not, but one of the things that you can see from this illustration is I can't quantitate accurately both of them. I can see the very large peak, but the small one is embedded or superimposed on the larger one. So if you think back to the previous illustration with the solid phase and the liquid, their chromatography and the expertise there is to separate those to a much greater degree so that I don't have overlap, because with overlap I can't quantitate them. So let's imagine if I took that shoulder and I thought it was THC and I was able to separate it and move it away from that really big CBD peak. And this is what happens when we have a product that's rich in CBD. That peak is very large, but the THC that we're looking for, the trace level of THC, is very, very small. So we need to use chromatography to separate those out as far from each other as possible, and that's called resolution. The resolution that we use here at Botanacor is greater than a factor of 2, which means that we can identify both the CBD peak as well as the THC. Now what you're going to look at is an actual chromatogram, not one that we have derived on PowerPoint. This is an actual chromatogram of a CBD product. And you can see there are a number of very large peaks, there are some medium peaks, and then some very small ones. What am I looking at? The very small peaks are called noise. They're created by the instrument or electronics, and they are random. There's a level of noise in every instrument, and you need to know that, because in order to determine that it's an actual peak, you have to see something above that level of noise. It's called a signal-to-noise ratio. In the US and in most countries that follow GMP or GLP, they use 3 times the signal-to-noise to establish that a peak is real. Once you have a peak that's above 3 times your signal-to-noise ratio, like you can see here, you know that that peak is a real substance that you can identify. Now, the next peak that you can see is about 10 times the signal-to-noise ratio, and that's called limit of quantitation. The limit of quantitation is a mathematical being that says, at this point, from here on out, the uncertainty of your measurement should be exactly the same from here through the rest of the dynamic range. But what happens between the LOD and LOQ? So the LOQ is the point at which you should be able to report with 95% confidence and make sure that your measurement uncertainty is the same throughout the range. From LOQ down to LOD, while I can clearly identify the compounds, the quantitation becomes a little bit less certain. So my uncertainty might go from, say, 7% at the LOQ all the way up to maybe 20% at the LOD. So one question that gets asked over and over is, can I actually quantitate below my limit of quantitation? And the answer is yes. It's just that the uncertainty will be larger, and it's important to work with your laboratory to know how big that uncertainty is below the limit of quantitation. So one of the things, and this is relatively new in the United States, is that laboratories will begin to have to put LOD as well as LOQ on the certificate of analysis so that you know where the uncertainty becomes more standard, and that you, if the values reported are between the LOQ and LOD, you know there's additional uncertainty there. So call your lab and ask, how much uncertainty should I expect in that result if it's between the LOD and LOQ? So I want to thank you for taking the time to listen to this, and I want to remind you that there are a couple of things that are very important. One, in working with your lab, make sure that they have sufficient separation or resolution of the compounds that they're looking at so they can accurately quantitate them for you. Two, make sure you understand what their limit of detection and limit of quantitation are, and now you know that while you can see at the limit of detection, the uncertainty is a little bit higher, and above the limit of quantitation, the uncertainty should remain fixed. The other thing, we haven't talked about that a lot, is to make sure that the products have been tested for safety. That includes a whole host of things: pesticides, heavy metals, microbiological contamination, and so forth. Those are the things you're going to need from your laboratory. If you have any questions, whether it's about this presentation or anything with your hemp or CBD analysis, send us an email or give us a call. We're happy to work with our Japanese partners.